In the previous video, we talked about different types of payment structures. In this video, we're going to talk about the present and future value of a single sum. If you'll open up page 2 and 3 and put them right together of the handout that is labeled Time Value of Money Chart, TIBA2 Plus. If you'll open them up and put them together so that they are page 2 and 3 are side by side like this, we're going to pretty much go straight across. Now again, what I would urge you to do is to stop the video and try the keystrokes yourself to make sure everything works like it's supposed to. So what we have, and we're just going to be looking at the top 4 rows for right now. So what we have is the present value of a single sum and future value of a single sum. There are 4 variables. There's the present value, the interest rate, the number of time periods, and the future value. There are 4 different formats for this type of problem. And you can see them there on the, I'm going to cover this up here. You can see them there as we go across. We have, in one case, we're trying to find the future value. In another case, we're trying to find the present value. In one case, we're trying to find the interest rate. In another case, we're trying to find the number of time periods. But all 4 have the same 4 variables. It's just a matter of which are known and which are unknown. So the first one we're going to give as an example, we know what the present value is. We know what the rate is. We know what N is. What we don't know is what is the future value. So the example is if you invest $150 today and earn 8% compounded annually, what will it be worth in 6 years? So here we have our $150, and we would show that probably as an outflow, so I think of that as a negative. We have 8%, we have 6 years, and the question is, what is it worth in the future? I would always urge you, until you're pretty good at this, to draw timelines just to show yourself where the cash flows are. Now, the mathematical format for this is that future value is equal to present value times 1 plus the rate raised to the n power. So if we were to solve that using our calculator, it would be $150 times 1.08 to the 6th power. And on this calculator, to do 1.08 to the 6th power, of course you turn it on, and that would be 1.08, so 1.08, y to the x, 6, because it's 6 periods, enter. And that's 1.59. Actually, this carries it to a lot more places because I've only got my calculator set to 2 decimal places. So if we multiply 150 times 1.08 to the 6th power, we get $238.03. On your calculator, the way you do this is you would first clear everything. So second, clear TVM. Second, clear work. And now we're going to solve it using the keystrokes for the time value of money keys. So we've got 150, change signs because it's going to be an outflow. 150 is our present value. So we click the PV. And then we have a rate of 8%, so 8 IY. 8 IY. 6 is our N. And now we're going to compute the future value. So we hit the compute key, future value, and we get 238.03, which, as you see, is the exact same number that we had before. Now, nobody really does this anymore, and I say nobody, not very many people, because the calculator is so good at it. So I would suggest that you get to be really good with your calculator to be able to make these calculations. It used to be, in fact, still in some textbooks, there are tables that have 1 plus I to the n power all over the table. So they'll have the rate across the top, and they'll have the number of time periods down the side, and every cell in the table will be 1 plus I to the n power, however, whatever the I is and whatever the n is. Of course, we don't do that much anymore because financial calculators took all that requirement away from us. So here we have 238.03. Now, some of you might come up with some weird number, and you're wondering, how did I get that number? Make sure that you have the payments per year set for 1 payment per year. So I'm going to click second PY, and it says 1 payment period per year. That's the only thing we're going to use in this course is 1 payment period per year, and we can adjust later to do it to consider other numbers of payment periods per year, but we're not going to use that key to do it. So as far as this class is concerned, just set your calculator to 1 payment period per year. Now let's look at a a present value problem. Again, we have the exact same variables, only this time we know these 3 and we're solving for this one. So the question is, how much do you need to invest today to accumulate $5,000 in 5 years if you can earn 10% annually? So we know what our future value is in this case. We know that there are 5 periods, and we know that the rate is 10%. We're trying to solve for the present value. Now, if you look at the future value formula and just turn it around to solve instead for present value, you could divide both sides by 1 plus I to the n power, or just multiply both sides by 1 over 1 plus I to the n power. In which case, we get that the present value is the future value times 1 over 1 plus I to the n. Remember, 1 plus I to the n is the future value factor, so we're just looking at the inverse. Well, if we take our $5,000 and multiply by 1 over 1 plus I, 1 over 1.1 to the 5th power, we would get $3,104.61. And that's perfectly fine, but we might want to use our calculator. And if we did, this is what we do. First, we go second clear TDM, second clear work, and just get used to doing that every single time. Then you have 5,000 as our future value. We have 5 as our n. We have 10 as our rate. And then we're going to compute the present value. So we hit the compute, PV, and we get $3,104.61. So it works just fine. Now notice that I put in 5,000 as a positive, and this 3,000 came out as a negative. And that's what you're going to have. There's going to be an opposite sign. If we go to the next problem, again we have the same 4 variables, but this time we're solving for I. If you invest $8,000, if you invested $8,000 6 years ago and it has grown to $20,000, what rate of return have you earned? So we know it's an outflow of 8, an inflow of 20. We have 6 years, and the question is, what is I? Well, this is actually a type of problem that you probably do want to be able to do with your calculator. Again, we're just manipulating this equation up here, but now we're trying to solve for I, so we're going to just turn things around a bit. And the way it works out is the future value divided by the present value to the 1 over n power, minus 1. And that's going to give you your decimal return, and of course multiply by 100 to get your percentage. So in this case, we have 20,000 divided by 8,000. And we're going to take it to the 1/6 power. 1 divided by 6 is 0.1667. So 20,000 divided by 8,000 is 2.5. Take it to the 0.1667 power, subtract 1, and you get 16.5%. I'm going to go ahead and track through that one. So I'm going to say 20,000 divided by 8,000 equals 2.5, and I'm going to go y to the x, 0.1667 equals minus 1 equals And I've got my calculator set to 2 decimal places, and for this it should be at 4 decimal places. But if I were to multiply that by 100, I would get 16.50%, which is what we have here. Or I could use my calculator's time value of money keys, which is easier still. So I'm going to clear everything. And I've got, by the way, it doesn't matter what order you put these pieces of data in, except this last one has to be entered after all the other data. So let's go with 88,000 plus minus is my present value. 20,000 is my future value. I'm going to do it just, well, 6 as my N, and then I'm going to compute my Y, and it's 16.50%. The final type of problem has to do with solving for N. So in this case, we know PV, we know FV, we know I, and we're solving for N. This is the problem. If you invest $500 today at 10% annually, how many years will it take to grow to $8,000? Sorry, $500 to grow to $800. So this is what it looks like, and I've got this little jag here because we don't really know how many periods it's going to be, so we don't know how far to draw it. We're not going to fool with formulas for this because it's way more than what we'd ever want to do. But here's how we would solve it using our calculator keys. We're going to clear everything. Second clear VM, second clear work. We've got 500 change signs as our present value. We've got 800 as our future value. We've got 10 as our rate, and we're going to compute N, and it's 4.93. So it would take 4.93 years to accumulate $800 if we started with $500. Again, it doesn't matter which order you put these in, but if you put in 500 without changing the sign, the calculator is going to come back and say error. So let's just so you'll see what that looks like. Again, I'm going to second clear TVM, second clear work, get rid of that. Now I'm going to do it the wrong way, which is to say 500 is my present value without changing the sign. 800 is my future value. My rate is 10. 10 is my rate. And I'm going to say compute N, and it says error. Got to have opposite signs, and it doesn't actually matter whether the 500 is the negative and the 800 is positive, or whether the 500 is positive and the 800 is negative. It's still going to give you the same answer.